Picture this. An indie developer sketches a rough concept for a 2D adventure game. They describe a forest scene to the system: ancient trees with glowing runes, a misty atmosphere, a character design blending Celtic motifs with futuristic armor. Within minutes, the tool generates concept art from text prompts using Apple's Core ML-optimized Stable Diffusion, refines voice lines for NPCs through 7 text-to-speech engines, auto-generates game code scaffolding via Claude Code integration, packages everything into a playable WebGL build, and deploys monitoring dashboards to track performance metrics. All assets flow through a single pipeline, versioned and reproducible. This is the core promise, a unified workflow where every creative and technical input becomes part of a traceable, automated production line. The user interacts through natural language prompts, drag-and-drop asset editing, and code reviews in a visual Kanban board. Outputs are game binaries for web and mobile, voice clips synchronized to dialogue trees, and analytics dashboards tracking load times or rendering bottlenecks. No context switching, no manual pipeline stitching. Underneath, 5 components divide labor. Phaser serves as the game engine backbone, rendering 2D scenes with WebGL acceleration while handling cross-platform deployment. When the developer adjusts a character's animation speed or tweaks physics parameters, Phaser's API surfaces those changes as live updating preview states. ml-stable-diffusion handles visual asset generation, optimized via Core ML for local inference on Max, meaning concept art and environment textures generate without cloud dependency. A developer could iterate on a cracked stone pillar designed 20 times without latency penalties. Voice acting and sound design fall to voicebox, which clones custom voices from reference clips or applies preset personas to dialogue. When the developer types a line like "Beware the shadow in the east," voicebox converts it to speech using Qwen custom voices expressive parameters, adds ambient reverb to match the forest scene, and exports it as a WAV file synced to the NPC's trigger events. The coding workload is managed by vibe-kanban, which bridges AI pair programmers like Claude Code with version control systems. When the developer drags a Kanban card saying "Implement day-night cycle with dynamic lighting," vibe-kanban spins up a workspace, lets the AI generate code using Phaser's lighting plugins, surfaces the diff for review, and auto-creates a pull request. Inline comments can tweak specific lines, add shadow softness parameter here, without breaking the flow. Finally, Prometheus monitors the entire pipeline. It tracks build times, memory usage during asset generation, API latency for AI models, and post-deployment metrics like frame rates on low-end devices. If the Stable Diffusion model starts taking too long on older MacBooks, Prometheus alerts the team to optimize the Core ML implementation or adjust batch sizes. This isn't a Frankenstein stack of tools cobbled together. Each repository solves one class of problems while exposing standardized interfaces. Phelps for rendering, ml-stable-diffusion for vision, voicebox for audio I/O, vibe-kanban for code velocity, Prometheus for systems health. The product layers them into a feedback loop where asset creation, programming, and QA are continuous, not siloed. The developer's job isn't to manage tools, it's to create, refine, and ship. Failed builds trigger exponential retry with catched asset fallback. A developer starts by sketching a game concept in vibe-kanban, where they split feature requests into Kanban boards. Each card triggers a workspace that spins up a Claude Code agent via vibe-kanban's API. The agent generates a Phaser boilerplate using the Create Phaser Game CLI, which pulls in the latest Phaser framework from JS Deliver via a script tag in the HTML header. The agent commits this to a Git repo, and Prometheus begins tracking build times under a Phaser init metric. When the artist requests a character design, they drop a text prompt into a VoiceBox-compatible field within vibe-kanban. VoiceBox's API proxies this to an ml-stable-diffusion worker container, which authenticates via API key and returns a 202 accepted status. The worker pulls the latest stable diffusion model from Core ML format stored in a shared volume, generates the image, and writes the PNG to a signed S3 URL. VoiceBox's event listener catches the image-ready webhook, updates the Kanban card with a thumbnail, and stores the metadata in a PostgreSQL table under game assets. For audio implementation, the designer selects a voice model in VoiceBox's UI, which sends a clone voice command with audio file references to the Qwen3 TTS engine. The engine responds with a voice ID, which gets embedded in the game's dialog JSON config. When the game builds, Phaser's loader component fetches the audio files from the same S3 bucket using Core's signed requests, while Prometheus increments its requests counter. During development, vibe-kanban's dev server routes hot reload requests through a reverse proxy to the Phaser Webpack instance. When the team runs npm run build, the output.js bundle is scanned by a Prometheus blackbox sporter that checks CDN latency across regions. The final build artifacts are pushed to a GitHub Actions workflow, which deploys to itch.io with a release-created event that triggers a voicebox text-to-speech announcement in the team's Slack channel. Each service maintains strict API contracts. vibe-kanban uses GitHub Apps for auth and emits Git-like events. ml-stable-diffusion requires XM's dates in headers for core ML model validation, and voicebox's TTS endpoints demand content MD5 hashes for catch consistency. Storage entities are isolated but referenced via shared UIs. Phaser's texture objects point to S3 keys, while Prometheus' game asset generation duration histogram includes labels for source repo and asset type. The data flow remains cohesive because every handoff includes enough context for downstream services to resolve dependencies without shared databases. Monitoring ties it all together, with Prometheus dashboards showing how long assets spend in each stage, from CAN card creation to CDN catch fill. Start with the game engine. Get Phaser running locally first because everything else stacks on top. Use the Create Phaser Game CLI to scaffold a base project with TypeScript. Indie teams need that structure without the setup tax. Integrate ml-stable-diffusion next. Wrap the core ML model in a Node.js service so it can generate art assets on command. Think of it like a backend endpoint that takes a prompt and returns a PNG. Keep it separate so you can scale it independently later. For voice, plug VoiceBox into this pipeline. Use its API to generate SFX or dialogue from text snippets. Write simple unit tests here. If the text-to-speech call returns a valid audio file, it's working. Don't get bogged down in voice quality, yet just verify the pipeline. Now layer in vibe-kanban. This handles the AI coding side. Set it up to watch your GitHub repo. When you create a Kanban card like Add Player Jump Mechanic, vibe-kanban spins up an agent to draft the code. Configure it to auto-commit changes and open a PR. Test this flow with small tasks first. If the agent messes up, it's easier to fix a broken PR than a half-baked feature. Local development needs Docker Compose. Define services for each component. Phaser Dev Server, ML Model Worker, VoiceBox API, vibe-kanban UI, and Prometheus for monitoring. Run Docker Compose up and verify all ports are accessible. Use lightweight base images to keep startup fast. Indie devs might not have beast machines. Background jobs are critical. Use Redis as a message broker. When an artist adds a new prompt in the Kanban board, queue it for ML processing. When VoiceBox finishes a speech clip, trigger a build task. Prometheus tracks queue lengths and processing times here. If jobs get stuck, alerts fire. For production, containerize everything. Use Kubernetes to manage scaling, especially for ML workloads. Deploy Phaser builds to a CDN, VoiceBox audio to S3, and vibe-kanban as a serverless function. Set up Prometheus with Alert Manager to watch for GPU memory spikes or API latency. Test the full workflow weekly. Generate a sample game. Create art, add sound, write gameplay code via vibe-kanban, build it, and deploy. Monitor the pipeline with dashboards. If any step fails, the team gets paged. This isn't about perfection, it's about catching breaks fast. Indie teams can't afford downtime when they're crunching to meet a release date. Keep the feedback loops tight. If the L model starts producing blurry sprites, adjust the prompt templates. If VoiceBox takes too long, tweak the queue priorities. The goal is a pipeline that hums along so the team can focus on creativity, not infrastructure. That's how you ship games, not just tech demos. To tie this workflow together, let's walk through concrete steps and limitations from each tool's documentation. Start with Phaser by installing the CLI globally via npm install g create Phaser game, then run create Phaser game and select a template. Configure environment variables like vite API URL, if integrating backend services. Note Phaser's MIT license allows commercial use, but requires including the original copyright notice in your game's documentation. For ml-stable-diffusion, first install Python dependencies via pip install our requirements .txt, then convert models using Python ml-stable-diffusion.convert, model name stability stable diffusion to 1 base. Deploy the Swift package in Xcode by adding to your Swift package manager. Apple's implementation requires macOS 13.0+ or iOS 15.0+, with performance varying by device. iPhone 13 or newer recommended for reasonable generation times. License is Apache 2.0, but ensure compliance with the original Stable Diffusion model weights terms. VoiceBox runs locally. Clone the repo, install Rust toolchain, then cargo build, release. Use VoiceBox clone to generate voice models from audio files, specifying language and or other supported codes. TTS engines like Quinn3 TTS require separate model downloads. All data stays local, but this means no cloud sync backup profiles manually. MIT license permits modification, but voice cloning may raise ethical concerns depending on use case. Vibe-kanban requires Docker and authentication with your AI coding agent. Run Docker Compose up after setting Claude API KE and env. Create Kanban boards via the web UI, then spin up workspaces with vibe-kanban start workspace, agent Claude. Note the self-hosted version lacks the managed cloud's automated updates, requiring manual Docker image pulls for updates. MIT license applies. Prometheus deploys via binary Docker or cloud images. Extract the tarball, configure Prometheus YAML with scrape intervals, then run. Prometheus config file prometheus.yml. Use PromTool to check recording rules. Apache 2.0 license. Default setup is single node. For high availability, federate multiple instances. Today, a developer could run Create Phaser Game to scaffold a base project, then integrate VoiceBox TTS by linking its output to Phaser's audio system. But how do you plan to handle AI-generated content licensing in your team's workflow?